Perfect. Hello, everyone. We have a very tight schedule today. To make the most of our time, I will skip our usual community update and jump straight to the session, to our guest speaker of today. Please note that the chat is disabled, but you can use the Q&A features for both question and discussion. And with this, it is my pleasure to welcome Karunakar Kotha, a former solution architect at Microsoft and an expert in cloud data. Karunakar, please share your screen. The floor is yours.
Yeah, thank you, Ronen. Thank you, everyone, for joining the session. Really appreciate your time. Let me share my screen. Let me know if you're able to see my screen.
Not yet. And please use your camera during the session if it's possible.
Ronen, are you able to see my screen?
No, but I could see it before when we tested it.
Okay, 1 minute.
Okay, I can see your screen. You are good to go.
Okay. Well, thank you everyone for joining the session. It was supposed to be a 90-minute session, but due to some emergency work that I won't be continuing for long, we'll try to make it quick 30-minute session this time. And I'll work with Ronen and the cloud-driven community to reschedule second part of session, which we want to do another 60 minutes, which contains a lot more demo and other work. For now, we'll try to make it very quick, 30 minutes. And if you have any questions, you can always reach out to me. Okay. Well, myself, a little bit about me. Myself, Karunakar Kotha. Currently, I'm working in Microsoft as a senior customer engineer, helping customers to migrate their workloads, both transactional as well as data warehouse from on-prem to Azure. And I work on the primary sector of airlines industry, which I deal with a lot of Fabric, OneLake, and now we are implementing a lot of on RTI, real-time intelligence. Today's session will focus on the basic fundamentals of the RTI, real-time intelligence, and how SQL Server has evolved from the traditional to one analytics and data analytics platform. Before going further, I want to tell you that where Fabric is the Microsoft Fabric RTI is the real-time intelligence is not a single product. In fact, I'll consider it as a toolbox. Each toolbox will give you some action items for you to implement and solve the problem, where RTI gives you end-to-end path for events from ingestion of your data and set of tools that you can perform based on the job of actions. The core tools we will use today is event streams, which act as an intaking of your data and grouping. Event house, which will focus on our KQL database, which is especially engine tuned for time series and logs. We'll talk about what is the use of KQL database and why it is most performance heavy on analytics systems. And also the real-time dashboards, where your systems and take decisions based on the system rather than traditional old dashboards where you need to wait for 30 minutes or every 1 hour to get your dashboard updated from your system, which we will focus on RTI, which is live monitoring. With live monitoring, there's another action or a tool that we want to use is activator. You want your activator job to apply some business conditions or some business logic where you convert them into actions. And with that, you need some agents or operators, sending the decisions back to your system, asking questions in NLP, like natural language, and provides more detail. So these slides will give you information about, it's not like RTI is a complete set of a toolbox where you identify what is the problem, what tool that I need to use for your business problem. Okay. Okay. So as I started my SQL Server journey from a SQL DBA, everything that I started working on SQL Server is stored procedures, functions, index tuning, database maintenance jobs, everything I considered as the problem back in those days when I started as my SQL Server traditional DBA. Now, as the data is growing, which is high volume, every system application wants to achieve low latency, high transaction data, okay, which now from traditional SQL Server database, we are moving to event house with the KQL database. So ultimate goal is that, you have a toolbox with you. We have a right tool to be performed based on your business needs. Still, some systems are completely relying on a SQL Server where they don't have any, high transactions or any event houses. Still, they can perform. But as Microsoft Fabric is there, we are navigating a lot of data to Fabric and implementing RTI for the real-time dashboards and events that we can use. Today, we are not going to cover, as I mentioned, about the time and the constraints. We are not covering a lot of framework and practical demos, but we'll talk about understanding about the Fabric Lake architecture and RTI features in the respective time. But next 60 session that I'll work with Ronan to work on the live demos and frameworks with the 2 different chapters that we want to cover. So this is the Microsoft Fabric, the picture, which contains a different set of sources. Think of an RTI as an entire loop. On the left side, event streams from devices. It could be IoT devices or from your applications or any other services. Event streams exactly sit at the front door, which I mentioned. It can be used for your capturing the data, which is part of your data ingestion, routes, and also some transformation of your data. Once event lands in event house, which we're going to talk about in the next slides. Once it lands in event house, it's a columnar distributed engine, which is very powerful engine where you can run your KQL queries. That is directly you're running on the analytical brain that makes your entire real time at a scalable practical, where you can say that this event house is very good for a large analytics data with highly performance queries that you can run using KQL. So you don't see any performance issues at all. And the third one is real-time dashboards, which presents the live picture. As I mentioned, it's a not near real-time data. It's a real-time data. That is what we are talking about, which contains the live picture, gives the right analytical data, and also you can drill out some parameters once we navigate to real-time dashboards based on your conditions you can activate to trigger some business alerts. Again, as I mentioned, activator comes to the picture when something happens, some business conditions happens, which could be a threshold. For example, if you want to monitor your performance of your system by if the CPU of the system is 80%, add or decommission any other existing SQL queries that you're running. This is where the activator comes in the picture, which on the back end, it runs some business conditions or a pattern. Think of activators like, it is the action and also with alert. Okay. You can also add some agents where you can ask your business analyst team in a natural language question. So, hey, what are the boundaries? What is the current condition? Can we change the conditions? So these agents will convert and make the changes to the actions or threshold of your real-time dashboards using activator. Across it all, you have one lake governance and security, keeping the data lineage, access, and policy consistent, because you want your system to be more data secure, right? So this is where you have implement the governance and security. With that entire thing in mind, let's zoom into the each engine, as I mentioned, how it works and why it is fast. Now, this is a Microsoft Fabric. Let me play this Microsoft Fabric work, focusing on real-time intelligence. Let me know if you're able to listen the audio. As I mentioned, all your team data, all you're in one place, which is Microsoft Fabric. Okay, I'm going to send that link to you if you want to revisit again. So as I mentioned, you want your entire team's or nation's data in one place, one lake, where you have a better accessibility and understanding what pattern of the data that you're using it, which is Microsoft Fabric, but we are focusing on RTA, which is called real-time intelligence, focusing on the dashboards. The question comes, maybe, most of you all worked in SQL traditional or any other NoSQL databases. We have a lot of other databases. Why we need another database like KQL database? Let's zoom out. As our business data evolved over the period, even the data engines also specialized. We didn't throw any tools, but we learned to pick the right tool or right database for the right job, right? So one line to remember is we have different data, and to support different data, we have different database engines too, different data engines, right? So here in simple map where x-axis completely mix of variety and velocity, which is you might have a data of XML, JSON, .txt, CSV file, Parquet files, and the velocity is where you have a huge amount of the data, which could be real-time batch or streaming data. Okay, and y-axis is the volume. As you move towards right and also towards up, problem looks like classical OLTP systems, like traditional OLTP systems that you want to solve, and more like a streams and telemetry. So on this map, SQL database, which is one of the popular traditional database, which is my database, which is my popular database, which is my favorite database, perfectly shines for asset transactions and enforce relationship, because you want to maintain this referential integrity and follows asset transactions. Data warehouse is great, perfectly great for governed T-SQL analytics. And Lakehouse performs favor for open Delta formats and also some Spark. Whereas KQL database, which is KQL, the event house database, excels in the top right. As I mentioned, it is perfectly suitable for real-time data that contains both time series, logs, and telemetry data. That's the event house sweet spot. That is the exact event house sweet spot, as you see on the right side, which contains perfect scenario and appends every time-based high cardinality data where you need answers right in seconds, not in minutes. You want the business decisions to make some value of the data, not by 30 minutes or latency of the reports or 20 minutes. You want to make immediate decisions, which is then right in a seconds. That is where the RTA comes to the picture, which is the event house KQL database. Concrete examples right now we have is IoT sensors, or any application telemetry, click streams, operation logs. Signals are always fast that we want to analyze and act on immediately, especially the IoT devices, the flight systems, operating systems, or digital transaction systems. So this is where the KQL event engine is perfectly used for business scenarios. So the main rule of thumb, keeping your transactions still in SQL to follow the asset and referential integrity issues. Land streams and telemetry in event house database. So you're landing them into event house. And you can use data warehouse and lakehouse when you want to shape your analytical data. And the best part is that you have everything in Fabric, which is one lake. No matter which engine you choose, the Fabric doesn't matter, like SQL, data warehouse, data analytics, RTI, event house, you have everything in Microsoft Fabric, which is one lake. So you can choose based on your database engine without any duplication or creating any joint correlate. So this is the right platform for you to use. Why another database? The main agenda of this slide is that it gives an idea about why you need to use KQL database. Right now, this slide could be a little, we need to update. This is the slide that I got in the last 2 months. Let me show some of the numbers this platform currently holding for our customers worldwide. Right now, about 10 exabytes of a month of events and logs, we are capturing it. Daily ingestion is around 350 petabytes, close to, okay? That averages to roughly about 4 terabytes for every second of the data that we're capturing it. The third read, we serve about 5 billion queries a day, around 60,000 every second. So right now, we have a huge number of customers running Microsoft Fabric RTI, which we have analyzed that 5 billion queries a day, which is very huge. Okay. Streaming volume leads at about 19 trillion events a month, roughly is around 7 million every second. And we keep it reliable, 5 nines. Of course, we want the best availability, success across the messaging pipeline, right from the data orchestration right from first source of truth to data visualization RTI. Okay. This is not the exact digits in the order of magnitude. Again, second to minutes, our global to scale data. The ultimate goal for you to tell you that the number of events that RTI is handling is increasing every day, and we are able to see a lot of customers onboarding to RTI. Again, this gives a little background about what is Kusto, what is KQL, what is a KQL database. To reach the massive numbers, we just saw that overnight does not happen. So Microsoft has been using and improving this technology for more than 10 years. Before that, can someone please tell me who is this left person who sit that you see on the visualization? So his name is Kusto. He's the famous scuba diver. So Kusto, the name Kusto Query KQL came from him because he goes as much as depth. Is one of the most popular Kusto scuba diver. His name is Kusto. So that's how the Kusto as name associated with that. So coming back to that, Kusto is not something that it has born now. It's a decade plus. It's more than 10 plus of analytics, production use, and inside doing some lot of work in Microsoft. It's started with just an introduction of the language called Kusto. As the cloud era took off, new services were spinning up everywhere, and telemetry exploded. Azure needed a purpose-built database, especially using for massive volumes of the logs, analytics, signals. The Kusto name that I mentioned about after Jacques' name is Kusto. His name is COU, is Kusto. The French ocean explorer, which explored a lot of the data in ocean, So the Kusto helped pioneer moderning the scuba diving, as I mentioned, turning the deep ocean into an explorable world. So that's the main spirit of deep exploration, is exactly what the KQL, which is nothing but Kusto, brings your data. So ultimately, the Kusto language is that um, it is used for high volume, high transactions data with more explorations, with less latency, high performance. Okay. So going back to the history, Microsoft brought it to the market in 2018, I guess 2018, as a data explorer. With it came KQL, turned for real-time analytics, time-based grouping, as I mentioned, especially for time series data, log data, fast summarization, and also detecting anomaly. All these things that you need whenever you have large volume of the data. And it is also optimized for data streams and time-based analytics data. Inside Microsoft, the engine is not only used for Azure, but also used for GitHub and other services that I mentioned. LinkedIn also relies on high volume operational signals that data right now. Fast forward today, right now, the Microsoft Fabric Event House brings the proven engines into Fabric with one leg governance, as I mentioned, with also contains the security and seamless integration and connections with all the Fabric services experience. So this slides gives a little bit about how we started the project Kusto and where are we with now, which is the Fabric Event House. This is a event house infrastructure of its scales with this different storage model, why queries are fast, out caches and cold caches. Okay. Now, as I mentioned, we'll understand about event house, why KQL is more optimized for large event data, large time series logs, operation data, whereas SQL is friendly, but used for ACID transactions. Event house, as I mentioned, that supports both SQL and KQL. Sometimes I talk to customers and they always get confused that hey, we like event house, but does it only support KQL? No, event house also supports SQL, because that's where you can also keep your source of truth as a SQL transactions data, as I mentioned. Why SQL? Because it's very familiar. You can always onboard very fast. It's perfect for catalog lookups or reference joins. As I mentioned, if it falls any asset transaction that you want to maintain. Okay. If you have a KQL, then if you have already SQL, then if you want to use KQL, different data, different tools. As I mentioned, KQL is a perfectly purpose-built engine that we build for real-time time series. You get time grouping, fast summarization, and also used for anomaly detection and quick visualization that you can build using KQL. And makes it as a most like a real-time exploration rather than SQL. Of course, you want to always have a dynamic data matters, especially when you're on telemetry payloads, often use a nested JSON. So we have seen a lot of customers are using for telemetry time series log, they are using KQL. KQL dynamic type and operator makes it very simple to explore, whereas SQL Server is very tough to make some changes to the schema. That's how KQL is used. And you can also explore other structures like arrays, objects without any making any changes to your existing ETL pipelines. When you're exploring, KQL also lets you add or record conditions, like a T-SQL, where but only thing that where SQL is more structured, where this you can always reorder conditions with a fix changes, and it bridges the gap while writing a SQL and translate to, if you have already a T-SQL query and you want to write them into KQL, Microsoft Fabric can translate to KQL very on the fly. So though you need to learn extra query language. So it's like a if you know SQL Server, if you know SQL, T-SQL, KQL, learning KQL is easy. Again, this is the order I want to explain, like with start time greater than some conditions that you can apply, give some visualization how to use SQL and KQL. Again, to make it very explanatory, I can tell you that learning KQL is easy as long as if you know SQL fundamentals, how to write a query. As I mentioned, right now we are building still a demo. This 30-minute session, we're going to talk about KQL understanding and some little bit of Fabric this session. And due to some work that I need to join another call, some emergency work. So we are doing another 60-minute session. I am working with Ronan and Data Driven Community to schedule another session in the future dates. And we'll publish another session very soon. I'm sorry and I apologize for all the inconvenience. We were supposed to cover 90-minute session this today, but due to some other work that other prior commitments, we are trying to make it very quick, 30 minutes. Next sessions, we want to talk about the demos and RTI data, some activator functions and conditions in the RTI group.
This was perfect. Thanks a lot for the session. And we will schedule a deep dive session with demos. Thanks a lot for joining us. I know it was a bit hard and we appreciate it. Thanks everyone for joining us. As we mentioned, today is a short session. Next week we will have a regular session, and join us. Go to the website, check out the upcoming session. Again, thanks a lot for the introduction and a great short session. It was really good. Have a great day.
Yeah. Thank you. Thank you, Ronan, for your time. I really appreciate. Again, thank you, everyone. I know we'll come up with a future date for another session dates, which will cover the more demo and more detailed way. Thanks a lot. Thank you, everyone. Thank you.
See you all. Bye bye.